Yes. Here we go. Let's go. Here we go. So this is what's the limit as n goes to infinity of -1 to the n squared plus 1? What is that? 0. Gets infinitely big, so therefore the whole thing goes to 0. Correct. So this thing goes to 0. Does each successive term, so does is an plus 1 always less than an? Yes, it is. It keeps on getting smaller. It doesn't go up and down, up and down. And then what's the last thing? Is it alternating? Which is really the first thing, because you wouldn't use the alternating series test otherwise. Alternating? Yes. Yes. So therefore, it converges. There you go. Good. Okay. What does the integral test tell you you need to do? Bingo. 0 to infinity of n e to the -n squared dn. N is the variable this time. Great. So you have to remember how to integrate that. Anybody remember how to integrate that? You can directly use u substitution on this one. What should u be? -n squared. So, sorry, u should be -n squared. So what does du equal? -2n dn. So what does dn equal? Du over, -2n. So now what do you do once you've set that up? No. The method is called u what? So what should I do now? Substitute. Yes. So you take this, you plug it in, and what do you end up with? The integral of n e to the u. Instead of dn, what do I write? Du over -2n. And do I have to change the limits of integration? Technically, yes, but what happens when I change the limits of integration on this one? They're the same. What's -0 squared? 0. What's infinity squared? Infinity. It's negative. So does it really? Do I need to do this? What do you think? Oh, awesome. Okay, how many variables do you see right there?
2.
No, I see more than that.
Wait.
What? You don't see 2 variables? I see n and I see u's, right? Yeah, I know. The u's and n's. Okay, correct. You're right. What's the magical thing that cancels right now?
The -2n.
The -2 does not cancel with anything.
No, the n.
The n does. So be precise in your language. N cancels. Correct. Yeah, I'll do my, here, ready? I'll do this. E to the u du. How's that? Yay! And we went like this, right? That's what we were talking about. Now here's the thing. Can you plug in negative infinity into an integral? No, you can't. So when you do this, this is what kind of integral? Indefinite integral. So we need to turn it into a limit after we integrate, right? So what's this going to be? -1/2 the limit as b goes to negative infinity of e to the u from what? 0 to? No, to b. We already pulled it out, right?
Could you exchange places?
You could. You don't need to. I want the constant on the bottom.
What happens when I substitute u for n squared as opposed to -n squared?
It should work out to the same answer.
Okay.
Now, here's the thing. What happens here? B is going to negative infinity. So what do we have here? We have -1/2 the limit as b goes to negative infinity of e to the what? E to the b minus what? E to the 0, right? We're plugging in those things now. What is e to the 0?
1.
This is 1. Well, b is going to negative infinity. So what does this go to?
0.
Goes to 0. So you end up with -1/2 times -1, which is what? 1/2. So does it matter whether or not we change the limits of integration on this one? Absolutely it does. Yes. Look where we went. If b went to positive infinity instead, what would happen to this answer? Now, first of all, what is this question asking us to do? It says, determine whether the series converge or diverge. So the thing that makes this a little harder is they're not telling you which method to use. On all the other ones, they tell you what method to use. They tell you what method to use. So this thing is n going from 1 to infinity. So before we decide what method to use, let's just think about what we know. What's the most interesting part to that expression right there, in your opinion? The sine of n. The 2? The 2 is elegant, which is fine. No, it's a subjective question. 2 could be the most interesting thing to you. Fine. It's my favorite number. You're absolutely right. In terms of the thing that you might be causing the most trouble for you is the sine, right? What's the thing you have to remember about sine n? No matter what you plug in, what is it?
Less than 1.
And greater than equal to? Negative 1, right? Do you agree with that? So what are the extreme values of this? It could be 1 over 2 plus 1, or it could be 1 over 2 what? Minus 1. All of the value, it's in between those, right? What's 1 over 2 plus 1? 1/3, right?
1.
And what? 1. This thing, all of the individual terms are between 1/3 and 1. So if you add them all up, what does this thing have to do?
Alternate.
No, there's no alternating. It must diverge because it doesn't go to 0. The only way for a series to have a chance of converging is if it goes to 0. Does this thing go to 0? No, it can't because all of the terms are between 1/3 and 1. So therefore this must what? Diverge, since the limit as n goes to n goes to infinity of an does not equal 0. The individual elements of the series, so the sequence, if you wrote this out as a sequence, does this sequence have any chance of going to 0? No. So therefore, can it converge? No. The first thing, it's like with limits. What's the first thing you check on a limit to see if you can evaluate it? What's the first thing you always check? Can you plug it in, right? Don't do anything crazy. Can you plug in the limit, right? For series, what's the first thing you should always check? Does it go to 0? If it doesn't go to 0, it diverges. But if it goes to 0, do you have to do some more work? Yeah, because just because a sequence goes to 0, does that mean the series converges? No. Harmonic, does it go to 0? Yes. Does it converge? No. Okay, Ali, well, this is an alternating one. So first of all, we know it's alternating. Why do we know it's alternating? Because of this thing, right? It's alternating. Does it go to 0? Yes, it does. Does each term get smaller?
Yes.
Each term smaller?
Yes.
So therefore what?
Converges.
It alternates, it goes to 0, and each term gets smaller. Therefore what?
Converges.
You can think of the absolute value of each term gets smaller. Like if you ignore the alternatingness. Done. Okay, put everything away except a pencil.